All right, welcome back. We've got a remote talk up next. Crushing cloud misconfiguration, mean time to recovery through open source. So before we start, I'd like to thank our sponsors, especially Bridgecrew. Bridgecrew by Prisma Cloud is the cloud security platform for developers. Built on open source, it finds and fixes infrastructure as code misconfigurations, enforces policies from code to cloud, and integrates throughout the development lifecycle. Try it out for free. So for those in the room, once again, we will do questions live after the talk, as well as taking questions from Slack and Twitter. Our speaker is remote, but he can hear us. So please welcome Steve. Cheers.
Okay. I'm assuming I'm good to go, and
go for it.
And you can hear me. Hello.
All set. Hello.
Yes, my name is Steve Giguere. Happy to be here. Super disappointed to be remote. Still trying to get over the hurdles of COVID to get people. I'm in the United Kingdom in spite of my accent. So in case you're wondering, that's why I'm not there. Yeah, this is good talk. Thank you. I'm going to share my screen just so we can see the content, which is really what matters, isn't it? Not my head. Alrighty. All right, good. Hopefully that's all good. We're all shared. Everyone can see my screen. Yes, this is Crushing Cloud Misconfiguration MTTR. What the real stars of the show are the open source tools, your automated infrastructure as code tag and trace. That might be a new subject for some of you, so I'll get into that. And chekhov, which is a fairly popular infrastructure as code scanning tool. Now, I'm going to be using those individually, but then combining them at the end, which should be a pretty cool result. My name is Steve, but we'll talk about that in a moment. More about me. Most importantly, I just want to set the scene. So we have a scenario where there already is something wrong in runtime, some form of misconfiguration. However that happened, we already have something set up to alert us. That could be misconfig, it could be CloudTrail. There's a variety of ways we can get messages to us. I'm picking on PagerDuty at the moment. And we have this misconfig found on an EBS volume. So Jane is our SRE in this scenario. And well, her job is to make sure this is corrected as soon as possible, but is she connected directly to development? Maybe not, right? So a scramble ensues, conversation, Brack to Nimrod, and they look at CloudTrail logs. They see that the server's account name is Terraform. That doesn't help them really very much. So in all, we end up with, of course, a Jira ticket. Is the Jira ticket assigned to the right person? Maybe it is, maybe it isn't. An imperative fix is done via the AWS console to bring things back into compliance. But that's only really temporary because now we've created something called drift where our runtime doesn't match our code. That's not good. And if something changes in the code, or perhaps someone in DevOps determines that there is drift, they might undo our good work to become more compliant or more secure. And then maybe we have another Jira, et cetera, et cetera. We end up in this loop. This is just one example, but I'm sure you can all think of many others. This is who I am. And I did try to throw a really rough phonetic spelling of how to say my last name up there. I am a dev advocate for Bridgecrew, big DevSecOps enthusiast, huge Raspberry Pi geek, and I have worked for a bunch of other companies. I also have a Twitch show and a podcaster, and I love beer. So enough about me. Let's get going. Very simple explanation. I'm sure this is maybe, bear with me. Infrastructure as code. This is how I explained it to my parents. Procedural versus declarative. Why do we have it in the first place? Well, to put it in sort of very simple terms, if I want to bake a cake, I get a recipe via procedural. Or if I just want to say this is my preference, of course, is to say, I wish I could do this in real life. This is the cake I want. Chocolate icing. I hate fondant. Chocolate sponge. Big 2 layers. This would be great if I could do that. And that is a provider I trust is going to create this to my spec. Now, the problem here we have here is when maybe I don't know the defaults. I don't know everything I can set, and something might not be correct. Maybe I create an insecure result, and somehow this needs to be changed. What is the fastest way of doing that? We can get from code to cloud pretty good. We're getting pretty good at that with infrastructure as code. But getting back from cloud to code, that's been our problem. And that's what we're going to work on. The problem happens here, for example, where I've deployed my cake, the cake has been created, and someone somewhere has determined that chocolate icing isn't secure enough. So now they moved it to concrete icing. There's a difference. So that's kind of the scene we're at. First star of the show is Chekhov. Chekhov is an open source misconfiguration scanner for infrastructure as code. You can go start using it right away. There's 500 built-in checks, best practices. It's open source, as I mentioned. You can scan a lot of things with it. You can scan, I'm going to use Terraform today, CloudFormation, Kubernetes, Helm, ARM, the lot, serverless framework even. 500 different rules, plus constantly growing. And there's a VS Code plugin, which is actually pretty cool. So I'm going to show you that too. The type of rules, well, we can get into that in a moment. But the gist of it is default configurations, disabling logging, unencrypted databases. These are the sort of things we want to be able to find. We want to be able to find them early. So now we're basically just trying to prevent ever having to deal with MTTR, aren't we? So how does it work? Well, if I just go to a console, for example, like this, I've installed chekhov. I could just do chekhov-d dot, and it's going to I haven't even told it what's there. It's just going to figure out what's there. It's going to put out a very colorful display. And I can see that it's looking for a secret. It does more than just misconfigurations. It's found a variety of secrets from entropy-based to authentication credentials. It's found a Docker file I didn't realize was in there, and it's found some issues for that. And then it's gone into a variety of different checks. These CKV2 ones are relationships between resources. That's a graph mechanism of scanning, which is very cool, very new as well. And then we move up to the top and we've got things that we're used to. So things you might not get right, though. Ensure that an S3 bucket has cross-region replication enabled. Okay, you might not get that right out of the box, and a whole slew of other wonderful things. Now, that's kind of a lot to consume all at once if you're doing the sort of shift left checks. My preference personally when I'm working with Terraform is to load it into VS Code. I go to Bridgecrew.cloud, I create an API key, and you're probably thinking, why do I have to do that? You have to do that to get the fixes, and there's a fix library that comes with it. So you see, Chekhov's already run here. I'm looking at this bucket. You can see what's wrong with it because I've tagged it with comments. But if I hover over, I can see all the rules I broke. So that's kind of like a bite-sized version of Chekhov. It's just installed. I've pasted the bucket, say from somewhere, and something's wrong. If I want to see what quick fixes are available, I can pop up and I can say, hit that. And you can see it's already picked up that this is a change in Git. I have versioning enabled. So I'm already solving my problems. That's super shift left. I don't have to deal with that in runtime, although it is something that could happen where I have to trace that back. That was a super quick intro. This is where you can find out more at chekhov.io. The next star of the show is yours really new. And it's kind of, I don't know of another tool that actually does what it does. Tagging infrastructure framework for infrastructure as code, automated tagging, strategic tagging, best practices, blah, blah, blah. But really, if you want to learn more, go check out that document, the AWS resource tagging strategy. We're not reinventing the wheel here. We're essentially automating what this says you should do and do it and coming up with the hard part, the how, the consistency and the strategy associated with tagging. And the result of that is actually surprisingly powerful. All of these use cases, again, we've taken them straight out of best practices, risk management, cost allocation, operation support, which is what I'm going to be doing now. But all that feeds back into automation console organization, which it kind of aligns with cost allocation a little bit. All of these things can be realized provided you tag your resources consistently. But what's really cool is you can combine the two tools I just showed you. This is an example of what it looks like. We'll see a real one in a moment, but you can see all the different Git tags that we just pull out of the box. And then one really important one called your trace. Your trace is kind of what's critical here. That is unique to the resource and the commit. And you might think, great, it's in a way of fingerprinting what that resource is and the moment that that commit happened to make that change, to identify that code in that state at that moment. Now, if you let your mind go, that's actually really powerful. So let's just take a quick look at what that really means. And I'll do it again here. Let's clear that out so we can get a clean screen. And it's pretty easy. I just do say your tag, very similar to Chekhov, right? Similar people made it, so it makes sense. And I can just say tag everything that's down here. And we can see there's a whole lot of output. I didn't have any tags in place, so it's kind of got kind of busy there. And then if I take a look here, we can see that all of these different files now have noted differences. We have all my Git tags. Pretty good. I've got this your trace. So if now that I've done all my tagging, ideally, the reality is I would do this in my CI. And it would be independent of the developer, although you can do it. It's idempotent so that you can run it here as a developer. When it gets into the cloud and it's checked in, you're going to end up with the same things. It's not going to modify. You can run it multiple times and we're all good. Now, what is the real advantage of all this? Now, let me just make a note. Once again, you can get more details at your.io. Say I have tagged everything and it's all gone into my cloud. And now remember that scenario that I told you about earlier. And I've gone into my AWS config and I've taken advantage of a lot of the default rules that AWS has there to check for compliance. And I've got a whole bunch of non-compliant stuff there, right? So I'm kind of freaking out a little bit. I have encryption turned off in a lot of places. I can click through here and I click through just for the sake of time in advance. And I can see my issues here. I've got I can just pick one of these and click through. And that was the one I decided to choose. Now I could go change this if I wanted to, or now because I've got this tag, I can come and say, all right, well, I mean, this is already really good information for me, right? I've got the name of the person who did it. Who is this person? Oh, wait, that's me. But I could grab this tag if I wanted to. And I can even see the demo goat repo. So I have demo goat open here and say, I search my repo for this. Now, say I'm going to get daring. I'm going to search all of GitHub, right? How unique might this be? There's no repository, but I can look at the code. I can see there's one result. Well, I can pretty easily click through there and even do that. Hey, there's that data bucket. And I can see the exact commit and I can see all the details again. There's the commit and there it is. So hold on here. Now I've just solved that problem that I had earlier, don't I? If this was an EBS volume, I would have been able to go into its tags, grab a short trace. I don't even have to know. I could have a huge organization. I don't even know where it is or why. But if I can do a global search, I can just find it. And now I've kind of solved my problem, have I? I could make it easier because now I'm really crossing the boundaries of kind of sec, ops, and dev in kind of reverse order. And I have kind of done a little experiment on how to fix that. I've got a repo here under my own called your Slack Lambda, where I wrote a Lambda function to kind of do what I just did. And what I did was AWS config triggers my event, CloudWatch event, which then fires this Lambda. And this Lambda takes advantage of a Slack webhook that I created. It uses the API, the AWS, which actually took a little while to figure out how to do that because it's kind of weird if you worked with that before. Figure out which one do I use. Grab all the get tags, construct a nice rich message, and send that to Slack. So if I run back over here, and by the way, I'm not going to put my real Slack on the screen because you'd see all sorts of stuff, but this is what it looks like. Now this comes into my Slack on the specified channel, tells me an S3 bucket is not encrypted, tells me it's flow logs. What's cool here is that because my Git is aligned with my Slack, which often happens, it's actually already tagged me. So now I've got kind of a DevSecOps workflow going on here. I've got a misconfiguration. It's important to security. It's important to ops. The right channel has indicated for ops to see this has happened, but also the developer has been tagged to see there's something going wrong there. And if anybody wants to see how it happened, well, I've added these convenient buttons on the bottom of the Slack. I could say trace on GitHub, and it jumps straight into GitHub. And now I'm back where I was, where I'm looking at a single result in GitHub. And I did that straight from Slack, straight from AWS config, straight from Lambda. Awesome. Not too bad. I'm pretty happy about that. So I'm already making vast improvements on my mean time to remediate because I've just showed a manual way and an automatable way. And all I'm doing is using open source so far. Not too bad. All right, how can we take this to the next level and maybe start looking for how we can find those misconfigs that I was talking about to remediate quickly? Wonder if I can do anything, because I saw chekhov and I saw your, and I'm like, oh, I wonder if I can use chekhov to do what I just did in a weird way or another. Well, we do have something in your, which is tag groups. So the Git tags, they were a group. The your tag was a group. I can make new ones if I want. And I've done that here. So I've got access level, and I'm tagging it based on the Git tags. So I'm reading those first is what your does, and then say, all right, any other tags I'm supposed to put on there? All right, so get org is your gig, which is me. This person's in development. It's kind of least privilege because development has the least ability to provision resources, operations a bit more. I wonder if I can create rules around that. That would be pretty interesting. Once I run this new your command, I'm going to get new tags, and you could see level and team there, development and platform to do with the executor there. Okay, so that's an interesting way of doing things. Now, I would normally add this to my GitOps workflow where I'd be running your and chekhov all together. For the purposes of this, though, I'm just going to run in here and do this manually. So I've got a second repo here, and I have already run your, and I can check this out by looking at Terraform, AWS, S3, and there we go. We can see that I've got my level and my team there, and it's assigned appropriately as I showed. My development and my SecEng, that's me. And I did that because I have my tag groups. Not too bad, right? So I wonder if this is going to enter into my pipeline, if I wanted to advance my pipeline. Right now I'm just running chekhov normally. What if I wanted to advance it and almost put some ownership rules or some permission rules in there? I can actually do that pretty easily. Now, if I wanted to, I could create a custom rule in chekhov. Now, I've got a custom rule I've created already, which is called check2.yaml. And I think I've got it over here as well. It is in my discote here, custom rules. I have just cloned this. Now, this repo is not quite ready yet because I'm not using these rules. I've just created it. These kind of rules are what create the CKV tool rules, so I can check relationships between attributes and the resource itself, or even other resources and attributes in very simple YAML. And if you want to learn more about that, again, same documents. The how-to on making these rules, you'd be amazed how short it is. There's only really so much logic you can apply, but what you can do between checking resources is actually extremely powerful, and all of those CKV2 rules are written in this. So it's pretty straightforward. So if I want to add that rule to my world, it's kind of pretty straightforward. So if I'm going to run, now that's probably a little hard to read. That's unfair. Let's do this. Let's pop that out there again. So I'm going to run the same chekhov I did before. I'm now getting external checks from that directory you just saw. I'm going to do compact just because it makes it easier to read on the screen. And I'm going to add that check that I just created by name. Now, I could not put that -- check in there, and I'd see everything, but I'd probably lose track of where my new check is. And I'm really just testing this rule works, right? So I'm going to run that, and it should pass. If we go back and take a look at the rule itself, all I'm checking is that there was a tag called level, that it exists. And that's pretty straightforward, right? So what I want to do now, just to kind of show you how I can improve on that, is the last thing I want to do is just check to make sure it equals. And I'm in development, but really operations are the only people who should be creating S3 buckets. Okay, so I've changed it. And now it should fail on my new check. Oop, if I spell it wrong, that's no good. Cutting and pasting under the pressure of live demos. And now I've failed that resource based on issues that I'm having with using your tags. Now, if I throw that all back into my pipeline, now suddenly I'm able to learn from some of my misconfigurations I see in runtime by feeding those back across security, across ops into development. But then I can start to say, all right, what are common? Can I create rules in chekhov so that I no longer see those problems in runtime? And I start kind of shifting even those things left so that I have new custom rules with chekhov that are taking care of some of my more common issues where I'm finding myself in a mean time to remediate loop. Okay, that's what I wanted to show you today. Key takeaways: open source is awesome. Shift left and then shift left again if you can combine open source tools to make those happen. And there's some really unusual circumstances. Everything is code is great. GitOps is the source of truth. Scan everything, but more importantly, tag everything. For some of you that might be a struggle right now, might be inconsistent, this is a great way to do things. And these are some of the ways that you can learn more about all of this. That is about it. I don't know if there are any questions. I can stop sharing my screen.
Thanks, Steve. You show searching through GitHub repos, but some of us have code commit, some of us have multi-repo, non-mono repo environments. Sometimes something that's committed to code doesn't actually get deployed at the same time. So any guidance on how we could find that your tag in more complex Git environments?
Ooh, that's a good point, actually. I'm not out of the box. I think the fact that it's unique across, regardless of the environment, right? There's no two your traces that will ever be the same. So I guess the way we would be able to search that is dependent upon a specific environment, and it would probably be a long answer to try and cover how to search every individual environment in the best possible way. I'm going to take that away because it sounds like a great blog article.
Makes sense. And then often with static analysis, a lot of the work is in managing and prioritizing the vulns that come up through this scanning. How do you recommend we track exceptions or false positives throughout the lifecycle of code if we're not going to fix everything that Chekhov flags?
You can add suppression comments. I mean, I didn't do that here because, and that's something you can do in terms of a shift left, right? If you're looking at Chekhov and you say, well, that's not relevant to me, the VS Code plugin will automatically do things like that for you. So if you say this isn't important to me, I can add a suppression, and then you can get yourself a clean slate on a Chekhov scan using that. I mean, the next level from that is, and not wanting to plug, but that's the kind of extras that the Bridgecrew platform takes care of for you. So that's the ability to suppress things, remember them, or create custom policies and distribute them at scale. That is, of course, the next level of what we're providing at Bridgecrew. So that feels like there's two answers there.
Makes sense. Any other live questions? All right. Well, thanks so much, Steve.
All right, excellent. Thanks.